Did you know that every single number has a secret code? Yeah, like a unique fingerprint that sets it apart from every other number in the universe. It's a code that's so powerful, it's actually used today to protect our most important digital secrets. And today, we're going to crack that code. We're going to use it to solve a puzzle that has fascinated mathematicians for centuries. Okay, let's dive right in.
So, let's kick things off with a puzzle. It's all about those weird numbers that seem to just go on forever with no pattern in sight. I mean, how do you even begin to prove something about infinity?
That really is the big question, isn't it? It's one thing to see the digits scrolling by on a calculator screen, but it's something else entirely to prove with 100% certainty that they will never, ever stop and never, ever fall into a repeating loop.
And the number we're going to put under the microscope is the square root of 2. It looks simple enough, right? But this number, a number you definitely ran into back in math class, holds a really deep secret about how all numbers work. So this is what we're trying to prove, that the square root of 2 is what's called an irrational number. Basically, you can't fence in with a neat little fraction. Its decimal just marches on forever, never repeating. But to prove that, we're going to need a special key. And that key is hidden in the very DNA of numbers themselves. You see, every number is built from a set of basic ingredients. And if you understand those ingredients, you can unlock all kinds of mathematical truths.
Okay, take a look at a big, kind of messy number, like 32,760. At first glance, it just seems like a random jumble of digits. But it's not. It has a hidden structure, a secret recipe, if you will.
And there it is. This number is built by multiplying 3 2s, 2 3s, a 5, a 7, and a 13. Now get this. This isn't just one way to build this number. It is the only way to build it using these prime building blocks. It's literally the number's unique fingerprint.
This whole idea has a very grand name, the Fundamental Theorem of Arithmetic. And trust me, the most important, most powerful word in that entire definition is unique. It means there is one and only one set of prime numbers that will multiply together to create any number you can think of.
This concept is so central to math that the legendary Carl Friedrich Gauss, they called him the Prince of Mathematicians, was the one who finally laid out a rock-solid proof for it. It's an absolute cornerstone of number theory.
All right, so we have our key, this fact that every number has a unique prime fingerprint. So let's go back to our puzzle and see how this amazing key helps us crack the case of the square root of 2. We're going to use a really clever technique here called proof by contradiction. It sounds complicated, but it's not. Instead of trying to prove that the square root of 2 is irrational, we're going to pretend, just for a minute, that it's rational. We're going to assume the opposite of what we want to prove and see if the whole thing just falls apart.
Okay, stick with me here. Let's walk through this. First, we assume we can write the square root of 2 as a simple fraction, a over b, in its lowest terms. That just means a and b don't share any factors. Okay, so we do a little bit of algebra, and we find out that a has to be an even number. But then, if we follow that logic just one step further, we find out that b must also be an even number. And this is where the trap springs.
And there's the problem. Do you see it? We started out by assuming our fraction, a over b, was as simple as it gets, no common factors. But the math led us to a conclusion where both a and b have to be even. And if they're both even, that means they do share a common factor, the number 2.
You can't have both. A fraction can't be in its simplest form and not be in its simplest form at the exact same time. It just doesn't work. It's a complete logical impossibility. Our assumption has led us straight into a wall.
So what does that mean? Well, the only way out of this paradox is to go all the way back to the beginning and admit that our first assumption had to be wrong. The square root of 2 simply cannot be a rational number. It must be irrational. Its decimal has to go on forever without repeating.
Now, you might be thinking, okay, that's a pretty cool mental trick, but is it useful for anything else? And the answer is a big yes. In fact, this whole unique fingerprint idea is the secret behind something you definitely learned in school, finding the highest common factor and the lowest common multiple.
Let's just take two simple numbers, 6 and 20. Here you can see their unique prime fingerprints laid out. 6 is made of 1 2 and 1 3. 20 is made of 2 2s and 1 5.
Now watch this. Once you have the prime recipe, finding the HCF and LCM is so easy. For the HCF, you just grab the smallest power of the prime factors they have in common. In this case, that's just a single 2. For the LCM, you take the greatest power of every single prime factor involved in both numbers. That's it. It's that simple. So what have we really learned here? We've seen this one single theorem solve a deep, ancient puzzle and make everyday arithmetic way easier. It's just a truly fundamental part of how numbers are built. And it all comes back to this one beautiful, unbelievably powerful idea. Every single number has its own unique recipe, its own unchangeable code made out of prime numbers. That fact is as solid as gravity, and it's the foundation for so much of the math that powers our modern world. Which leaves us with one last thought. This idea of unique prime codes, it's not just for old-school math problems. It is the absolute bedrock of modern cryptography. You know, the science that keeps your emails, your bank account, all of your digital information safe and secure. So what other secrets do you think are out there, locked away, just waiting for us to find the right prime key?